Fantastic, fantastic. Well, welcome everyone to another one of our Serverless Guru webinars. Today is, I'm also really excited for today. We have Daniel back on from our Serverless Guru team, and he's going to be talking to us about building a serverless GeoIP API, specifically featuring API Gateway, Lambda, S3, and S3 Select, which I am not as familiar with. So this is really exciting, and shout out to what is it? This super spooky theme for Halloween. So we promise you that what is it? The technology is not as scary as the slide, so it's much easier to understand. But what is it? So what is it? This webinar is sponsored by Serverless Guru. We are a serverless first cloud consultancy with partners and engineers from all around the world. So we're serving a global clientele, and we help industries and individuals, as mostly enterprise organizations, streamline their serverless development and streamline their serverless transformations. And if at any other point you are listening to this presentation and would like some more direct assistance with how to leverage a broader suite of serverless technologies to sort of increase your business's bottom line and to increase your developer and product velocity, please feel free to reach out and you can talk to Daniel and I a bit more, as well as the rest of our team. And with that, I can hand it over to you, Daniel.
Okay, so just a few words about me in case you weren't here in the last talks I had. I'm doing cloud since more than 10 years, serverless since it started in 2016. And I used to work with servers before. I happily moved over to serverless to not have to deal with all that OS maintenance and hardware IOPS and so on. You still have a little bit with serverless, but obviously it's less. And as I said in the description for this talk, like having to spin up an EC2 again, it's kind of like, oh damn, what's an SSH key again? I forgot. What's an ALB group? What's a load balancer? What's a autoscaling group? Like after not having touched the EC2 family since a few years, like suddenly like, yeah, I was like, oh yeah, I don't have this pain anymore, and I was really happy. And that's one of the reasons, like this serverless Geo API, like having the word IP and API in the same sentence is really hard. And to have that, like, helps you to have a service that you don't have to manage your infra to get something that has a lot of throughput, that gives you the data you need. So you will see later during the presentation how it helps and what is useful, why it's useful to have it as a serverless application. So first, just like the layman's slide on what is an IP. So I hope there's nobody in the networking industry that's listening to that and will destroy me on all the insanity I talk here. So basically, in a world where we have only IPv4, which is no more the case, and we don't have multicast or private subnets, like every hardware on the internet has an IP address. So it's the way it's unique, and it's the way that devices, be it a client and a server, or an IoT device and a server, discuss to them and know how to find the route to go there is an IP address. And this IP address is always like sent to the server, because the server needs to know where to send the response back. So that's not something you can hide or like a cookie. So it's something that's always sent to the server. So the server will always know which IP is calling him. Then you have a little bit of like weird cases, basically because IPv4 has a limited amount of IPs for the world. So most of the devices in a household have behind your router that will do NAT. So it means that all the devices in your household will share the same IP seen from internet. And since the IP is always sent to the server, so the server can know who is calling him, and by knowing who is calling him, he can gather information from that. And that's what the GeoIP database will be, is getting information from your IP to know where it is, because IPs are allocated to ISPs or companies, and they're located by continent first, and then each continent by country, and then by company. So it means that an IP address, it's like not really moving from one country to another in a short time frame. So if you reassign, you will reassign a whole subnet, generally a /24. So /24 is the last number here, moving, changing. And you can easily know which, for an IP address, to which country it belongs. And for some databases, you can go as precise as a city, or at least as a, in the US, you would call that a county, so like an agglomeration of cities. But careful with that, there's a lot of false positive. It's often the city is assigned to the HQ of the ISP. So if I take in my example, Vodafone Portugal, the HQ is in Lisbon. So basically most of the people who will have a Vodafone IP will be located as Lisbon and not the real city where they live in. So depending on the precision you need, you will be sure that Portugal will be the right answer. But then for the city or for the state level, you might have false positives. And there's an easy way to look at to whom an IP belongs. Is using on your laptop the whois command. And if you type an IP address, I took that from my old home long time ago. And by just typing that, I can see that the ISP is ViewQuest and the country is Singapore. And that's something that will stay pretty constant for a large amount of time. And there are people who have built databases as those that do a mapping from IP to country. So the one that's probably the most well known is MaxMind. There are a few other services out there, IP to location. There are a lot of free services too, but obviously the more free, the less accurate. And these services are expanding to not do only IP to country, but also to do databases of known VPN endpoints, to have IP addresses of known Tor exit endpoints, or known fraudster for like credit card fraud. So having these IP address databases is really helpful in most of the application when you want to filter out the bad traffic. So why do we want to build an API? So there are databases. If you go to the MaxMind, so the whole demonstration here is built on MaxMind's databases. So you can buy the databases, you download a binary file, you install it on your server, and you have SDKs to query that binary file in a really efficient way. So with an SDK on a server with a binary file, so you have this binary file that are awfully fast. So you really get quickly your result. But the cons is every time you autoscale your server, you will need to download the new files, update them, keep them up to date, keep the keys there. And it can only be accessed for the application on that server to a tunnel, not a tunnel, a socket. And with an HTTP API, you can basically call it from anywhere. It's HTTP. So you can make calls from EMR, from Glue. You can make calls from a Lambda function. You can make direct calls from any SPA, so a web app, or for a mobile app. And you only have to maintain the freshness of your data in one place. But the cons, obviously, there, it's slow. Just having HTTP will add an overhead on your calls. It will, but you can, if you have some caching in place, and we'll see that later on in the slides, you can actually reduce the time, but it will still be not as fast as the binary file. So you have to make a compromise like between time of maintenance or energy needed for maintenance and the speed you want. Which solution is the best for you? And now, why do we build our own? Because commercial services like, especially MaxMind, they offer APIs. And in a commercial service, you will generally pay by request and per DB. So if you need distributed DBs, which is GeoInside, GeoCity, and GeoCountry, you will need to pay for each of them. And then you will get some latency because it's generally outside AWS. In the example, MaxMind, I think, at least when I did these slides, which, to be honest, they are like 2 or 3 years old now, they were using Cloudflare. So you have to go out from your hosting, from your cloud network to go to another cloud network to get information. So you have the HTTPS latency and you have the network latency added to that. So with your own serverless API, you still pay by request. You have to pay address for that. You won't pay for idle, which is the same case in commercial generally. You will need to pay for the DB storage, but you have no servers to maintain since you are serverless. And you're able to use, in that case, the free DB offerings. Like MaxMind has a free database called GeoIP, which is updated once a month, and obviously way less precise than the paid one. So if you really need that in a production environment and you rely on the data, don't go for the free one, pay for it. And being on your own cloud or in your own account, you will get lower latency. You can start to have private APIs to inside your VPC to make the connection. And you can start to mix and match different databases. And we will see that in the demo I have set up. I have 2 different databases that I mix. So I have a GeoIP from MaxMind and I have another database behind the same API. So now the big question is, why S3 select? So I think the first is like the geek answer is like, because I can. And I mainly needed an excuse when S3 select came out in 2017. I wanted an excuse to use S3 select in a real project or in a real need project for 2 reasons. First, I want to do an internal POC to show my colleagues that S3 can be used as a database. It's not just for file storage. And at that point in time, DynamoDB didn't offer an on-demand pricing, so I had to use a provision throughput, which would have been expensive. And S3 is a nice storage. You just put in there your file and they stay there forever. You have almost no chance to lose them. You can always access them. So that's why I went for S3 select. So since Josh doesn't know what S3 select is, I made this slide for him to explain exactly what it is. So S3 select will allow you to query a file that is structured, where you know the structure of the file using SQL language. The main goal when it came out was to be able to query large files in S3, but only load the data that is needed to your application. So if you have a Lambda function that needs a few lines from this huge, let's say 1 terabyte file, and you only need like 5 or 6 rows, why load 1 terabyte into Lambda and then do a filter when you can do an SQL query on the file and just get the few lines you need? So you can support multiple file formats and compression. So read CSV, JSON, Parquet. You can compress with gzip, Snappy, or BitZip2. And it's also like a fun DB backend. Like if you want a little DB, you don't want to go to RDS or the serverless offering from RDS. You just have one file, a CSV that you exported with from Excel or elsewhere, and you just want to use that as a DB. Think a little bit like SQLite for the cloud. And on the right, you see some code example in Node.js to how to write a query. So you will pass in, like you do a get file, you pass in a bucket, a key. And then you explain how your file is. So you need to know your file format. You will say, I want to do SQL, I have a query, and my file is a JSON lines. So it means it's like multiple lines. Each line is a valid JSON document, but together it's not. It's compressed with gzip, and I want the output to be JSON. And then I just send that with the AWS SDKs as a select object content. And it will, in that case, will select the username from my S3 objects where the age is bigger than 21. So it's basically, I want to check if the guy is allowed to drink for Halloween in the US. In other countries, they will be already allowed. So for this GeoAPI, what's the flow look like? So we have like 2 components or 2 two sides of the application. One is the producer and one is the consumer. So on the producer side, we will periodically to a CloudWatch event or a cron job, if you prefer, download the zip files of these databases and put it into an S3 bucket. On this S3 bucket, we have an event, and every time there's a new file, we will trigger another Lambda that will basically unzip the file and store the content of this file in another bucket. Then again, another event on that bucket that will do that triggers a Lambda that shards the data into the final bucket, which is basically our data, which will become our database. So the reason I used Lambda bucket, and so on, and no other event sources, is that when I did that, I think there were not many great options in terms of event triggering. And having Lambda attached to an S3 bucket as an event was a really easy way to get started. And then on the consumer side, we'll have your clients through Route 53 will come to a Cloudfront distribution that we'll call an API gateway, which invokes a Lambda, and the Lambda will run the S3 select on the final sharded files and then return the result. And the reason we have these two sides of the project is the producer will run basically when new files are published by the provider, in our case, MaxMind. With the light databases, the free databases, it's once a month. So the producer here will run only once a month per databases. So if you have like 3 databases, city, ASN, and country, the producer this Lambda function will run only 3 times in a month. And on the consumer side, it will run as much as you have requests coming in. So you separate the production of the data from the consumption of the data, and so that you reduce your cost, or you keep your cost in check for that. So if you look at the source file, and we're like saying we unzip and we shard and so on. In a zip file, we have 2 files. So one is a CSV of IP blocks that look like this. So you have this 202.83.140/24 that belongs to a certain geo name, and it has coordinates, and it has an accuracy radius. And then in the GeoName database, you will get for each language the GeoName ID and what it belongs to. So in our case, we're working only in English, so I know that this number here will be in Asia and it's Singapore. And the next one is in Europe, France. And they even have this little nice tag to say, is it in the European Union or not, which allows them to apply your GDPR rules or whatever you need to do, which is specific to Europe. And so why do we do sharding? So we do sharding so that the S3 select will reduce its need of scanning. So S3 select will have to scan the whole file to do the query, and you pay by the amount of data scanned. So you basically pay your S3 select request by the amount of data that is read, like that is stored on S3. So by sharding, you allow to reduce the amount of data scanned. So you win in cost, you win in speed. So we're doing here is a sharding by network head. So I call network heads the first number in the IP address, because there's no subnet in the GeoIP database that is bigger than a /8. So that will overlap 2 of the first numbers. So basically, all the subnets that are inside 202.something, I put them in a 202.gzip file, which will hold maximum, if each IP is uniquely identified as a line, 16.7 millions. If you look at the whole IPv4 spectrum, it's like 4.3 billions. Obviously, we will have less because, as you've seen in the previous one, it's not stored IP by IP, but it's stored by subnet. And then to be able to query easily, we will convert all IP addresses to an integer. And to do that, and that's basically how IPv4 notation works. It's all in 2 power something. So the first one is 2 power 24, 2 power 16, 2 power 8, and 2 power 0. And you just sum that. So if I look at my /24 for this IP, it will go from 0 to 255. So it means that the minimum is this number that I won't spell out, and the maximum is this number that I won't spell out either. And my IP that I'm looking for will have a certain number. So then you can just do a query. So you S3 select SQL query to say that my network range start is bigger than this number, and this number is smaller than the network range end. And that will give you one row from my 202.gz file. So if I look at the files that we stored in S3, my 202.gzip will look something like this. So it's a JSON line file. So you have 1, 2, 3, 4 lines in this example that will have a certain validity date, an updated that date, and we'll have some data. So we have a continent, we have the country, and the network head, and then from which IP to which IP it's valid. And then you do, as I said before, a select from S3 object. When my network range start is smaller than my number, it gives me one row that I can then pass in my lambda function. So what kind of API endpoint are we able to build with that? So first is everything related to IPv4. So we have /IPv4 with just the IP address, which will just give 3 databases back: country, city, and ASN. Then if you just want country, just want city, you just want ASN, by adding the /country, /city, /ASN, you just get this information. That just allows you to load less data into your functions. Then another endpoint, ifconfig, which will give you the information for your own IP, for the caller IP. Just the minimum. And here with detail, we will get all the country, city, and the ASN endpoints. And since I have my geonames files, I decided that why not have a country that code, and it gives me, like, for my ISO code, the country name. And I was saying in the beginning that we can mix and match databases. So I have another database here that has nothing to do with IP, which will give me the location of a specific Cloudfront edge. So if I take the edge identifier of a Cloudfront request, by doing that, I can get the geolocation or the coordinates or the country and region where this edge is located. And to make that possible is that Cloudfront edges are named after IATA airport codes. So I just have to download the database of airports and use that to identify my Cloudfront edge and know where it is. On the caching side, I went for that really, really easy. I used basically just Cloudfront to cache it. So I put Cloudfront in front of my API gateway, and Cloudfront will cache. If I go back to my path, Cloudfront will cache based on the path. So the IPv4 / whatever number I use here / country will be cached in Cloudfront for subsequent requests. And in Cloudfront, we can control the cache by either max age or expires. And since I know when my data will expire, because I know the update schedules of all the IP databases, I can use expires and put a certain date in there. So my data will stay in Cloudfront until that date. And when using locally with Cloudfront, so when I say locally, it's from a Lambda function to the GeoIP service. My first request was 184 milliseconds because of cold Lambdas, but and no cache. And once it's cached, subsequent requests are 20 milliseconds, which is still really slow compared to a binary local file. But it's totally acceptable for the few use cases that I had. If you want to see the code, it's on GitHub. I can just use it. It uses serverless.com as a framework, and it uses Node.js as a language. At that point, when I wrote these slides in 2 years back, was still like, some people were still like, yeah, Node.js is not made for Lambdas. It's just like stuff like NVM or Webpack or NPX are just like lifesaver when you code for Lambda functions. So the maxfind key is put in an SSN parameter store. I transform all the coordinates into geo points. The reason for that is to be able to load them easily as in a map in Elasticsearch. Elasticsearch accepts GeoPoints as an entry. I just protected my API with an API key, which is really like, yeah, shouldn't be done like that. And I put a custom CloudFront, and I didn't use an API edge optimized, so I can control the caching mechanism on CloudFront and not rely on whatever API gateway wants me to do. And where did I use that? So the first application I needed it was to parse Cloudfront logs. So all the logs that Cloudfront was producing, I parsed them and I enhanced them by first knowing where the edge is. So in the Cloudfront logs, you will get the IP address of the person who requested it and which edge he was using. So by using the combination of the Cloudfront edge and the IP to country, I was able to know in which country the customer is and which Cloudfront edge he was using. I was also using that on some ETL jobs. We had like an analytics sync with data, and we know the IP of the person, of the customer requesting our content. And using that, I was able to combine like country, city, and ASN. So ASN basically will kind of give me a hint on the ISP he's using. And the other fun part we used was in a mobile app. Some people were complaining that the quality of the data they received in the app was slow or was like not as expected. And we had a debug page in our app that by hitting a button, they were like calling the GeoIP service. So we knew from a simple click in an app or a tap in an app, we knew what client he was, what country it came from, what edge, Cloudfront edge he's using. So we could actually start to debug and see if there's a problem with his network or it's just something else. And we did also like on a web app, a listing display where we were looking at having like filtering out content based on your country. So a little bit more details on the Cloudfront log processing, why it was useful. With that, I was able to gather information like download times per ISP or ASN. And that's so it could actually identify if some ISPs were better than others in some regions, or if an ISP was like had always like a bad connection, like start to like either talk with him or talk with AWS to try to improve his interconnection between him and AWS. Another part also was like trying to find like city or country of a customer and which Cloudfront edge they were using, and to look if this Cloudfront edge made sense. And in some area it didn't. So you can then take this data and go back to AWS and say, look, why are these customers in this country like hitting an edge that's so far away where another edge could have probably been better? And then you can just have plots like consumption of data per country, since the Cloudfront logs will give you the number of bytes downloaded. And by passing the query strings, sorry, the path of the request, in our case was for movie qualities, you could actually then make pie charts of, for each country, what was the kind of quality that the majority of users is getting. Like, is it like mostly towards the 360 or mostly towards the 1080p? Okay, so if you look, then I made some plots like this, like country versus edge. So we can see that like in a customer in Pakistan will go like kind of everywhere. A customer from Singapore will only hit the Singapore edge, and someone from Germany will go like mainly to Frankfurt. And this kind of data was really useful for us to see which countries there were like issues and which country was like doing fine. And then I spoke from a video quality serve, we can say like, oh, in this country, Pakistan, there was like mostly 360p, whereas in Singapore, it was like 1080p and a little bit of 720, and Germany was like towards the high quality, but still some lower qualities. So that's all fake data, by the way, it's just for illustration purposes. Don't come and say like that's the truth. And then, yeah, traffic by country, you can have a map like this, and you will just see that like India is downloading the most, and then a little bit US more than Canada, and Australia is kind of similar to US. So you can start to have in your dashboards this kind of maps and plots. So I have a little demo that we will try. I hope it works. So I already deployed it, because with Cloudfront it always takes so much time to deploy. But just to show you, I have an API gateway. I have my endpoints here. You see like IPv4, the IP and the DB type, which will all trigger a Lambda function. And just to show you that the data really exists. I have here the source file that I downloaded. So let's take the GeoIP country. So that's my unzipped file already, which has a manifest file and the IP blocks and the locations. And once we shard them, we'll have like for each network head a gzip file. So that goes from 1 to 255. So let's try now to call that. I did one just before to test. So here I just want to get the information of this specific IP address. I just took that randomly. And it will give me the response. It's in Europe, it's in the Netherlands, it's in a city now called Strijen, if I am able to pronounce that correctly, in a region called South Holland. And here are the coordinates if you want to plot that on a map. And you get the ASN, which is in that case KPNBV. I don't know what that means, but at least if I want to group by this value, I can. And that's perhaps too much for our application. We just want the country. So if I do a /country. So you've seen it's taken longer than the first one. The first one was already in Cloudfront cache. This one was a new request that I never made before. So it had to go back to API gateway, Lambda, and S3 select. And here I have only my country information, so continent and country. And if I do the same request now again, it's like now getting super fast. Then there was like another endpoint, which is just if config. So that will give the information about my home IP. So my home IP is this one. But if I want some details on that one, singular or plural? Singular. Oh, JQ. To make it look nice. Okay, I'm in Europe, in Portugal, in Lisbon, which is actually not really true. And I'm on Vodafone, which is correct. And now looking at the Cloudfront edge endpoint. So let's say I do a, let's do a curl-v. So I think they show it now in the header. Yeah, now I have the Cloudfront edge that I am using. So I'm using this Cloudfront edge. So I guess you already can guess from the name where it is, because this name is like nice. So I just pass in the edge name here, and magically it should work. Yes. Oh, sorry, JQ again, forgotten. So this edge is in Lisbon, and here are the coordinates, and in Europe. Some edges are a little bit more cryptic. If you see the edge like CDG, you probably have no clue where that is. So that's in Paris. So I think that's kind of it for the demo. If after the presentation you have, or perhaps now, if I don't know if there's questions about that.
Doesn't look like we have any questions yet. If anyone has any questions or can think of anything, please remember to either post it in the chat or the Q&A section. Looks like you're probably fine just to continue a bit. And if something comes in, I can let you know.
So now on the cost estimate, because that's always like interesting to see like how expensive or how cheap it is. So I said we have a monthly fixed cost because we have storage, we have files to download, and we have this content to produce. So it's basically 120 megs of storage. So it's like 1 cent of puts and 1 cent to run the lambdas. And then on the request side, if you have like 100,000 requests, it will be like 80 cents. So the prices are perhaps not more accurate because it's kind of, again, old slides. I went into my attic and found some old slides for Halloween. So the Lambda will cost you 85 cents. S3 Select, it's kind of somehow expensive, 13 cents. You still have to pay for your S3 gets and you have to pay for Cloudfront. So a monthly estimate on basically roughly 1 million requests a month. You have this 3 cents of fixed cost, which are like really peanuts. And then it will depend if you request a cached or non-cached. So I kind of went to like 10% non-cached, 90% cached, which will give you a blunt total of $2.55 for a month, which is basically like 0.0 something 26 per request. So if you see for 1 million requests, or even if you go like 2 million requests, you still are below $10 a month. So what improvement could be done here? Because obviously there are a lot of improvement can be done. This first is move to DynamoDB instead of S3 Select, and you can keep the exact same logic of sharding. So you could use your primary key as the network head, your secondary key as the network start number. Sorry, your range key and your hash key, and your hash key being the network head and your range key being the network start number. And surprisingly, it's like storage for Dynamo and storage for S3 are kind of the same price. Request-wise, they're kind of the same price. So I think in my math, it was slightly more expensive, like 2 cents more. Then you could use, once you have Dynamo, you could use VTL in the API gateway to directly query Dynamo instead of having a Lambda function. So you reduce your Lambda invocation cost by 85 cents. You could use Elasticache or now MemoryDB to store your data, but obviously that's like something like a high jump in cost. But you win the $1.15 of Cloudfront. For the producer side, you could use step functions or CloudWatch events, like not have like Lambda hooks on S3 events every time. The auth will need to be obviously better. The API key protects your API, but not Cloudfront. And with API gateway proxy, you could use the same API and still call the commercials API behind it. So that would be another way to do it. Or AppSync to get some GraphQL power, so to like really like let the client choose which fields he needs back instead of having an endpoint/city/country. You can start to like use GraphQL logic to merge or filter out this data. And yeah, that's it. So it was shorter than I expected. Yeah, perhaps a few words. Oh no, I have another demo. Sorry. I toyed a little bit today with, since the files are in S3, I said, why not use glue? Because I never did glue on these tables. So I run a crawler on this ASN country and city databases. And they were able to index it nicely. And then you can start to like query them built in Athena just to show, or it means you since it's in Glue, you can use your EMR job or PySpark jobs to use this data for your ETL scripts, and no more have to rely on HTTP APIs. So you get back the speed that you lose by the HTTP API. And I did a few fun queries just to have something to show in here. So one was like, yeah, I'm wondering how many IP addresses each country in the world has. So I just run this query where I select the country name and the number of IP addresses and getting the count. So not surprisingly, US comes out in the top and followed by China. And US actually comes out at top by a lot. And then I did another query. I come back to this one later. What was that? City for IP. Yeah, that was like basically the number, like all the cities. They're just the 10 first ones. Oh no, that was like that's to get the data for one specific IP address. So in my case, it's my IP. Where I do this same query that I do in S3 Select, but I do it here in Athena. So I just had to do the math here to calculate this 2 power 24, 16 and 8. I think Athena doesn't have an inbuilt function to change from an IP address to integer, but you could do that with a UDF. Or if you load your data into a Spectrum, Spectrum has this functionality to convert an IP address to a number directly. So we didn't have to do this ugly math here. And using Athena, I also exported another data set, which was IP by ISP, and that's a fun one. Let me come back to my export after. And because this one like scared me a little bit. You see that the first ISP, it's not an ISP, it's an ASN number, basically. I call it ISP, but it's a wrong spelling. Like it should ASN. And the first one is a Nginx AS, which has a really like way more than others. And when you look up on Google, who's that? It's actually the Department of Defense. So back to my query I did, I exported the data by city in a flat form in a CSV file, and download the CSV file and uploaded the CSV file into a QuickSight, just to see what else can be done with this data. I tried to connect directly QuickSight to Athena, but I wasn't able to do it. Probably the data that I have is deeply nested. I've been seen the JSON, and QuickSight doesn't really like that. So I would need to flatten the file before being able to load. So I just exported the result as a CSV and uploaded the CSV. So I'm working based on a CSV file. And if you see, it's like a 1.3 gig file. Can I see the content? I forgot how to do that. Long time I didn't use QuickSight. But I did some plots here just to see with this data set what can be done. So again, the same as I did with my Excel file, but here in QuickSight, having the number of IPs per country as a pie chart and also as a world map. So the darker the color, the more IPs this country has. And then here was the sum of IPs per city. It was mainly to see how the cities are being able to spread out, like how precise can a city be. And if I zoom in into, I should be able to do here, if I zoom in into, I think in the US it's not too bad, but if I zoom in into Europe, I was kind of surprised to see that they are like more spread out than just the capitals. I was expecting to see more points in just capitals. And if you look at this region here, you see that the Lisbon region is a bit more dense, the Madrid region is a bit more dense, and that's because most of the addresses will be with the HQ of the companies that to whom the IP belong, and these HQ have like a higher probability to be in these cities. But even here, it's the know that there are some IP addresses that will be in this point here, which is, if you guess the city name, can I see the in Vichy? Yeah, Vichy. Or here it's like multiples. So yeah, so you can start to like export your data, enhance your logs, add this geo information to you or IP based on the IP addresses to your data sets, and start to get like fun plots into your dashboards. And yeah, now it's the end. Now I've, I think, shown everything I wanted to show.
Oh, thank you so much, Daniel. I know this has been really, really interesting, and definitely enlightening too. And now I know what S3 Select does, so even better. So if anyone has any particular questions, please feel free to add them in the Q&A section or add them in the chat. We'll wait a couple minutes. And if there aren't any questions, well, one thing I definitely can say is that, you know, everyone will be getting a recording of this webinar. Plus, I think Daniel is usually really good about sharing some of the code or sharing some of the demos as well as the slides with everyone. So everyone should get access to that as well.
Yeah, I will send the slides to you, Josh, or to
Yeah, I would send them to Jonathan, and Jonathan will help distribute everything.
Yeah, I will send him that and the URL to the Git repo if someone else wants to toy with that.
Sure.
But yeah, it has to be like my Git repo has to be taken as a toy and not a production ready app.
Okay. Yes, exactly. Exactly. And Daniel, a question I had is if you know, if you had a choice, because you had talked about sort of like maybe the next steps or the things that you could do after, do you have one that you would probably lean towards like doing first or trying first? Like if you wanted to apply this to like more of a production use case?
Yeah,
like,
it's DynamoDB.
DynamoDB.
Move to DynamoDB. So S3 Select here was more like the geek inside me that said, let's use something that's like out of the norm, and having something like not just a POC, but having something that's used in real life every day with like processing log files, especially like it was for a movie app. So we had a lot of these log files, and processing these log files with an S3 Select was kind of showing everyone else like, yeah, S3 Select is actually usable as a database. It's not, obviously it's not Postgres or MySQL, but for some type of content, it's actually easier than having to spin up an RDS.
Okay. Okay. No, that's good to know. Okay, so DynamoDB is the first step. All right. All right, team. Well, you know, what is it? Well, I may be able to save everyone another 12 minutes in their day if everyone blocked out an hour. And, you know, so get an extra cup of coffee or take a walk outside and that sort of thing. But any other last points you want to give Daniel, or if people want to like reach out to you or ask you specific questions, you have a place for them to reach you at?
Yeah, I generally like Twitter PMs or messages in LinkedIn generally reach me.
Great. Fantastic. So, yeah. Fantastic. Alrighty, team. Well, thank you so much, everyone, for coming on to the Serverless Guru webinar today. And, you know, any other questions, please feel free to reach out to Daniel, or you can contact us. Everyone will be getting a recording of the, recording of the webinar as well as the slides and that sort of thing. So this is fantastic. Always happy to host and always happy to have you on, Daniel.
Yeah, well, happy to be here. It's always fun.
Exactly. It's fantastic. All right, team. Well, everyone, wherever you are in the world, have a fantastic rest of your day. Good evening, good morning. And we are close to the weekend. So I hope everyone has a fantastic weekend. And if you celebrate Halloween, have a very spooky holiday.
Thanks. Yeah. Bye, everyone. Thank you for
attending.
Everyone.
Take care, y'all.